Okay, so this is the first lecture for Unit 2. It covers atomic and molecular structure. When you do this lecture, you should have a periodic table handy. If you need one, they're in my classroom by the front door, and just go ahead and take one and use it. So today we're going to look at how to relate the position of an element to the atomic number, the atomic mass, what's it mean, those sorts of things. And we're going to talk a little bit about isotopes. So first, atoms are composed of protons, neutrons, and electrons. So protons and neutrons are found in the nucleus, electrons are found outside the nucleus. One element is different from another because of the number of protons. So different elements can have the same number of neutrons, they can even have the same number of electrons. But it's the protons that make one element different from another. And that's a question I do like to ask on exams, is what makes one element different from another, or how do you differentiate between elements? The atomic number is found at the top of your periodic table. So for example here, if I have a box on the periodic table, 2, He, and 4, this number here on top is the atomic number. And that works for about, I'd say 90-95% of the periodic tables you find the atomic numbers on top. And that represents the number of protons in the nucleus. So helium right here with element number 2 has 2 protons in the nucleus. If you find carbon, okay, carbon's element 6, and therefore it has 6 protons in the nucleus. Now, right now, the number of protons will equal the number of electrons. So if you're not sure, okay, about the protons, or the electrons rather, if you're not sure about the electrons, right now it's the same as the number of protons. That will change in a later unit when we start to talk about ions, and at that point what's going to happen is elements are going to gain and lose electrons. But right now we keep it simple. The pluses equal the minuses. So if we practice one here, okay, we did carbon, we found carbon on the periodic table. Carbon has 6 protons and 6 electrons. Phosphorus has 15 protons and 15 electrons. And these symbols that I'm using right here, it's supposed to be a lowercase p plus and E minus. Those are the approved symbols for protons and electrons. And if you take a look at gold at the periodic table, it's down towards the bottom. In the middle, you should find that it has 79 protons and electrons. You can also use this to go into the other direction. If I want to find the element that has 8 protons, the element with 8 protons is oxygen. Okay, so this works backwards and forwards. You know the number of protons, you can figure out the element. Now, the mass number is the number of protons and neutrons in the nucleus of an atom. So this is your symbol for neutrons, and with a little 0 at the top because it is neutral, it has no charge. So with this formula, we can pretty much figure out anything that we want, okay? Because we also already know that the protons are equal to the electrons. What you have next here is called a complete symbol, and it contains the symbol of the element, the mass number rounded to the closest whole number, and the atomic number. So this mass number right here, you would round it to the closest whole number. So the mass number is the number at the bottom of your element symbol in the periodic table. So round this to the closest whole number. So for example, when I drew helium before, helium had a 2 on top, He, and a 4 on the bottom. This 4 right here is the mass number. Oxygen, element 8, it's got a symbol of O, it has a mass number of 16. So that mass number is what's going to go right there on top. And the atomic number this number here, my 8, is what's going to go down here on the bottom. And you'll see in a moment why we flipped them. It's going to make our life a lot easier for something I'm about to show you. So if we do the complete symbol for carbon, so here's carbon, we find the mass of carbon on the periodic table, round it to a closest whole number, and that's 12. Carbon is element number 6 on the periodic table. So that's the complete symbol. Well, when we set up the complete symbol this way, all we have to do is a quick subtraction, and that's going to tell us the number of neutrons. So carbon has 6 neutrons. If I do another phosphorus on the periodic table is P. If I find the mass number, that goes on top, and round it to the closest whole number, that should be 31. And then down at the bottom is the atomic number, which is 15. If I subtract those two numbers, that's going to tell me how many neutrons there are. Now at this point, you should pause the video and try uranium and hydrogen on your own. And then once you think you've got them, go ahead and restart the video and check yourself. So uranium is towards the bottom on the periodic table, and when we look at the mass of uranium, it is 238. It is element 92, so that is uranium's complete symbol. Do a subtraction, and that's going to give us the number of neutrons, 146 neutrons. Hydrogen, all the way at the top, there's our symbol for hydrogen. Hydrogen has a mass of 1 and an atomic number of 1. So hydrogen has no neutrons. And that's just the first sign that hydrogen's weird. Okay, we're going to see over the course pretty much of the semester that hydrogen does some weird things that the other elements don't do. And the first thing is it has no neutrons in most cases. Okay. So for each of these, I want you to find the protons, neutrons, and electrons, and then the atomic number and the mass number. So again, this is a point where you should pause and try this on your own, and then check yourself. Okay, so for my number of protons for A, this is 35 protons. I get this from the atomic number right there. For my number of neutrons, to do my number of neutrons, what I need to do is I need to subtract these two numbers. I subtract those two numbers and I get 45, and that's my number of neutrons. My electrons are equal to my number of protons. So if I have 35 protons, I have 35, if I have 35 protons, I have 35 electrons. The atomic number is right here. This is my atomic number. So 35. And my mass number is this at the top. And so my mass number is 80. Okay, same thing. Here's another one. This one's slightly different. So again, pause the video and then try this one out. Okay, so with this one here, okay, this time you're not given a symbol. So you're told the atomic number is 34 and you have a mass of 78. So your number of protons is the same as the atomic number. So since the atomic number is 34, my protons are 34. That also tells me my electrons, 34 electrons. Okay. With my neutrons, what I do is I subtract my mass from my number of protons, and that gives me 44 neutrons. And then lastly, my complete symbol. The complete symbol comes from, okay, here we have the mass, which is 78 on top. On the bottom is the atomic number, 34. And then you'll use this atomic number, 34, to find your symbol on the periodic table. So if you take a look on the periodic table, you find element 34 and you find selenium, Se. Okay. So that's how you would get your complete symbol, is again by looking at the atomic number or the number of protons. Okay, next question. 91 protons and 140 neutrons. Try and figure this one out. Okay, your atomic number is the same as your number of protons, so your atomic number would be 91. Your number of protons is also equal to your number of electrons. Now, mass, your mass number is equal to your protons plus your neutrons. My protons are 91. My neutrons, given up here in the top, is 140. So you add those together and you get 231. Right? And you do the complete symbol. So the mass number goes on top, 231. Down at the bottom goes your atomic number, which is 91. And then you want to find number 91 on the periodic table. This is why it's really important to have a periodic table in front of you. Find number 91, and that is protactinium, I believe. Yeah, I have to double check. Yep, Pa, protactinium. Right. Okay, one more. 78 electrons at 117 neutrons. Looking for the atomic number, the mass number, number of protons, and the complete symbol. Okay, so again, pause this, try it out. Okay, we've got 78 electrons on this one. So 78 electrons means we also have 78 protons. 78 protons also gives us our atomic number. Mass number is equal to protons plus neutrons. Well, I've got 78 protons plus 117 neutrons. I add those together. Let's see, that's 195 for your mass number. I go ahead and write the complete symbol. Mass goes on top. Atomic number goes on the bottom. We look up element 78. And element 78 is platinum. Okay. So you might have noticed that a few of those masses don't match what was on the periodic table. And it's not that I made a mistake, it's that I was dealing with isotopes. And isotopes are essentially like different flavors of elements. Let's say you have an element that's a ball, okay? There's different types of balls out there. So we would call like a tennis ball, a soccer ball, things like that, an isotope. What really makes one isotope different from another is the number of neutrons, okay? All atoms of gold have the same number of protons, that's 79, but they don't always have the same number of neutrons. And so we call those different ones isotopes. And if they're going to have different numbers of neutrons, that's going to give them different mass numbers. Okay, so these are what we call isotopes. And essentially, it's just a way to think of it. They're just a different flavor of the same exact element. And that extra flavor or different flavor is caused by a different number of neutrons. And some of them are just made that way. Some of them are made that way out in the universe. Some of them are made that way in a nuclear reactor. Some of the isotopes are radioactive, some aren't. Some live a long time, some disappear very quickly, okay? But one way you know you have an isotope is by the way we put the mass number after the name of the element. So carbon on the periodic table we saw earlier was 12. This here is carbon 13. And it is a radioactive isotope of carbon. So if I were to write the complete symbol of this carbon, instead of the 12 off the periodic table, I would take the 13 and put the mass there. Carbon is still element number 6. It still has the same atomic number. And if we wanted to figure out the neutrons, we could. This carbon has 7 neutrons. The carbon I showed you earlier had 6 neutrons. Okay. This is carbon-14. It's another isotope of carbon. This one's used in radioactive carbon dating. Okay. Carbon-14. The mass goes right up there at the top. Don't overthink it. Ignore what's on the periodic table. This is telling you what the mass is. Carbon is still number 6. Okay, that hasn't changed. And now this carbon, you can see, has 8 neutrons. So most of the carbon in the world has a mass of 12. But there's a couple of isotopes out there that have a mass of 13 or 14. And that's because they have an extra neutron. Now, uranium you can figure out is the same way, but I wanted to show you guys here another one. This is another way they might write an isotope. Again, earlier we did hydrogen, and remember we did hydrogen, it was like this, 1 over 1, and we've had it with 0 neutrons. Well, this is hydrogen 2. And I know it's hydrogen 2 because they give me the little 2 at the top. So they've already filled in the mass number for me. So down at the bottom, all I have to do is put in the atomic number. And they figure we're smart enough to figure that out. Hydrogen's element number 1 on the periodic table. And so this flavor of hydrogen has 1 neutron. Okay? There's actually another type of hydrogen out there that has 2 neutrons. And these are just naturally occurring in seawater. So one more here, nitrogen. Let's clean this up a little bit. Okay. We've got nitrogen, and this is called nitrogen 15. I call it nitrogen 15 because it has that 15 at the top. You find nitrogen on the periodic table, it's element 7. You can do a subtraction if you're asked to find the number of neutrons, and you can see you've got 8 neutrons in nitrogen 15. Okay, so working with isotopes is pretty easy. We're actually going to work with isotopes more in the 3rd and 4th lecture in this unit. On my website, there is an exit slip, so I'm going to navigate over there real quick. I still would like you to do the exit slip. Okay, so even though you were absent, okay, if you go to my web page here, Unit 2, Atomic Structure, so under Chemistry, there's now Unit 2. You click on that. This was Lesson 2A. You click on Lesson 2A, and the web page is going to look a little different because right now I'm recording the video lecture that's going to go right in here. But here you can see, here's the exit slip that you'll fill in, and I would like you to complete this. You do need to write me a question. Everybody does. Okay, and I do answer it. And then right down here is the assignment turn-in page. So again, please fill out the exit slip so I have an idea of your understanding. You do get points for doing it, but I don't take away points if you get the wrong answer. Okay?